Hey everybody, it's Mrs. Harbin. Welcome to Video Notes 1.1. We're going to be doing these 5 bullet points here as our objectives. Alright? So make sure when you start these that you look at these objectives, and make sure when you finish these that you look at these objectives. I'm going to help you do that by putting them up for you. So, moving on. You'll have to take some book notes. Please read and take notes on Chapter 4, Section 4.3. A good way to do that is to look at the headings, look at the titles, and then find the main ideas and write them down. Draw some pictures. Okay, so early models of the atom. We think matter is made of atoms. At first, the thought was that atoms were just spheres that were indivisible, and then they found these negative particles called electrons, so we had to put that as part of our model of the atom. And then they found this positive center of the atom that they called the nucleus, and then these electrons. And so our model developed over time based on new scientific evidence. More recently, so early 1900s, the Bohr model of the atom was able to help explain these, which are called line spectra. Every element had its own unique line spectra, kind of like a fingerprint. Okay, so we still thought that atoms had a nucleus with the protons and the neutrons in it, and that the electrons were, so here's the new part, where the electrons are in these energy levels outside the nucleus, which is almost right. Although this model of the atom was able to explain most of these spectral lines, but it didn't say how the electrons moved around, just that they were able to move around. So it's almost right, except for the new information that led to our current model of the atom. So I'm not going to tell you the current model of the atom. I want you to read these 2 pages in the book and then come up with the current model of the atom, and make sure you put it as a title for current model of the atom. But still, in our current model, we have those protons and neutrons in a central nucleus in an atom, and the electrons are in energy levels. That's still true. But how do you describe the electrons? You describe them as occupying probability clouds in those energy levels. Not orbits like this, but probability clouds, which describe where the electrons are. Okay? So just to make sure I re-emphasize the main points of atoms, which make up matter. Atoms have protons in the nucleus. Those protons are positively charged. They have a mass of 1 AMU, and they actually determine the identity of atoms. They help us know which atom is which. Okay. Also in the nucleus in those atoms are neutrons. Okay, neutrons have no charge. They also have a mass of about 1 AMU, and because of the neutrons in an atom, you can tell the mass of an atom, the neutrons and protons, but the neutrons help determine the mass and whether atoms are stable or not. Electrons are in clouds outside of the nucleus. Electron clouds, they are negatively charged, they have negligible mass, which means compared to those 2 heavy things in an atom, the electrons are really not that heavy. And the electrons help determine the charge of an atom. Alright, so what is an atom? An atom is a neutral building block of elements. So please draw this picture in your notes and label each part. What part should you label? The nucleus. You should label the protons. You should label the neutrons. And you should label the electrons. Okay, so why are atoms neutral? Atoms are neutral because the number of protons, and in this case there's 6, is equal to the number of electrons, and in this case there's 6. So overall, this atom has no charge because the positive and negative equal each other. Okay, so atoms are building blocks of matter. Atoms are neutral. Atoms have all of these parts, and the reason they're neutral is because the positives equal the negatives. Okay, so another term you have to know in chemistry for sure is ions. So what's an ion? Well, it's an atom that's not neutral anymore. So it's really not an atom because it's an ion. Why is it an ion? It's not neutral anymore. It has charge. Okay. So atom or ion. Well, this one has to be an atom because it's showing you that it's sodium. Sodium has 11 protons, so we're going to assume that's in there. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 electrons. So that's neutral. That's an atom. Sodium, in order to be sodium, has to have 11 protons. So this is still sodium, has 11 protons. but now it only has 10 electrons. And so overall, it has a +1 charge, an extra positive compared to the negatives. How did that happen? Well, this outside electron goes away. Okay, so atoms are neutral. Ions have charge. So you can have two kinds of ions, the kind that have positive charge, and I want you to figure out what the charge is over here. So this has 7 protons and 7 neutrons, and 2, 4, 5, 6, 7 electrons. So is this an atom or an ion? Protons equal electrons, so it's an atom. So that's just nitrogen. So this has 7 protons and then 7, 8, 9, 10 electrons. So it's got 7 protons and 10 electrons. So what's the deal with that? This is a -3 ion because it has 3 extra electrons. Did the protons in the nucleus change? No, can't change, or else it's not nitrogen. What makes an atom turn into an ion is the charge, which happens because this one has 3 extra electrons. The charge on this one happens because it has 1 less electron than it started with. Okay, so there are 2 kinds of ions. There's the cation, which has a positive charge. Positively charged ion by loss of electrons. All right, an anion is a negatively charged ion by gain of electrons. Okay, so ions are charged, cations are positive, anions are negative. Okay, so what can the periodic table tell you? The periodic table has a very important number on it. It's called an atomic number. Atomic number equals proton number. It is the whole number on the periodic table. Nitrogen has 7 protons. So if it doesn't have 7 protons, then it's not nitrogen. 7 protons, nitrogen. Nitrogen, 7 protons, atomic number 7. Okay, the other information is the symbol of the element, the atomic mass, average atomic mass, and some have electronegativity too. Okay, so we can also symbolize different elements with this kind of symbol. It's called isotopic symbol. All right, so an isotopic symbol has this top number is the mass number. So for this one, the mass number is 238. The bottom number is the atomic number. So this one, the atomic number is 92. What does that tell you? Number of protons. So that's how we know it's uranium, because the symbol of the element goes here. The only element that has 92 protons is uranium. So we know these go together because that's what makes it the identity. This number, though, is then the total of the protons in the nucleus plus any neutrons. So that's isotopic symbol. Isotopic name, or the name of the isotope would be uranium. Name of the element, uranium. And then a dash, and then the mass number identifies it. This is uranium-238. This is the name. That's the symbol. Okay, so an isotopic name is element dash mass number. Mass number. Okay, isotopic name, element dash mass number. Isotopic symbol is symbol, mass number, atomic number. Okay, so isotopic notation, if you want the name, you name the element, dash to the mass number, symbol, symbol of the element, mass number, atomic number. Okay, so if there's no indication of charge, then it's neutral, so it must be an atom. So let's play atom or ion. Dun, dun, dun. All right, U-238-92, atom or ion. Dun, 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 dun. Hopefully you said atom because you don't see a charge. Atom or ion. Well, this has a negative charge here, so it must be ion. Atom, no charge. Ion, charge. Atom, no charge. That means it's neutral. Okay, atom or ion. Atom, woohoo, because there's no charge. All right, atom means there's nothing up there. All right, so I want you to classify those 3, and we'll talk about them in class. All right, so once you know whether things are atoms or ions, you can figure out how many protons, neutrons, and electrons there are. Okay, so this is helium-6. Helium-6. So we know it's helium, so we know there's 2 protons. All right. We know it's not charged, so there's also 2 electrons because it's neutral. Those equal each other. And then we know it's got 4 neutrons because this number is 2 plus 4 to get 6. protons plus neutrons. All right, this is oxide ion. Oops, I said ion. How do I know it has a charge? So let's see, how many protons? Well, it's oxygen, and that's 8, so 8 protons automatically. Atomic number is protons is 8. Electrons. Well, this is 8, and it's got a charge. What gives something a -2 charge? Extra 2 negative things. So 2 extra electrons, so we have 10 electrons, and then 16 minus 8 is 8 neutrons. Okay. This is a nitrogen atom, 7 protons, so it's got no charge, 7 electrons, and then 12 minus 7 is 5 neutrons. This is an ion, all right, so we have 11 protons because atomic number is protons is bottom. So if it's got 11 protons and it has a plus charge overall, then it must only have 10 of the negative things, so it's got the extra positive. And then 23 minus 11 is 12 neutrons. Okay. All right. How many protons, neutrons, and electrons if you're given the name of an isotope? Well, it might help to write the symbol and the atomic number. Okay, so now we know we have 26 protons. We have 24. I can add. Really, I can. Oh, wait, that's only 50. 26, 28 neutrons. Okay. Since there's no, it doesn't tell you anything about a charge or an ion, it must have 26 electrons. Okay, neon 20. Neon 20. All right, where did I get the 10? From the periodic table. So 10 protons, no charge, so it's 10 electrons, and then 10 neutrons, because this total top number is protons plus neutrons. Potassium ion, oh, it tells me it has a charge. Now I know a little bit more about potassium than you do, so I'm going to tell you that potassium has a +1 charge. Okay, so we have 19 protons, or it's not potassium. And then since there's a plus charge, there must be only 18 electrons because there's an extra net positive, and then 21 neutrons. That's a 21 neutrons. Okay, not 211, it's 21 peeps. Okay, so, okay. So how do atoms of an element differ? Well, we have these things called isotopes. We've characterized isotopes. This is oxygen, this is oxygen, this is oxygen. How can they all be oxygen but have different numbers? Well, here's where neutrons help you know the mass. So these are called the mass numbers. And so they are atoms with different mass numbers. Mass number. Atoms of same element. Okay, these are all oxygen, but they have different mass numbers. Okay, why? Because different number of neutrons. It can't be protons, or else that changes their identity. So it can only be neutrons that differ. So that's what isotopes are. So these are 3 oxygen isotopes. So average atomic mass. This number down here is not a whole number, but if it's protons plus neutrons equal the mass, why isn't this a whole number? Well, the reason is because it's an average. If there's these 3 kinds of oxygens found in nature, then we have to take an average to figure out the mass of any oxygen sample. But we don't take a straight average because most oxygen is oxygen 16. So if the class average is 71.2, there's really not a person probably that has this exact average. So there's really not an atom of mercury that has this exact average, but if you take into account all the isotopes of mercury, you can get that average. It's not a straight average, it's a weighted average, and that average atomic mass is usually going to be closest to the type of isotope that's most abundant. So aluminum has 2 isotopes. Aluminum's average atomic mass is 26.982, which is closest to 27, so this is probably the most common aluminum you'll find. Silicon, most common silicon. Probably this, because this is closest to 28. Argon, let's see, argon 39.948 is closest to 40, so this is probably the most common isotope of argon. I want you to try to figure out what the most common or most abundant, meaning which isotope of phosphorus, which isotope of chlorine, which isotope of sulfur is probably the one you'll find the most of in nature. Okay, hey, it's raining outside, you might hear the thunder. Okay, so how do they calculate that average to put on the periodic table? Well, they have to know the mass of an isotope, and they have to know how much there is of it in nature, so 99% abundant. And you multiply those together, And you get for this one, all right, 1595.2632. Okay, if you multiply those together, you get 0.647324. If you multiply these together, you get 3.59795. Now you might say, okay, now what? Well, then you add together all of those, and you get 1,599.50847. Now, this is not the average atomic mass of this element, because these were all percents. And when you're working with percents, you have to change them to decimals by dividing by 100. So divided by 100, you find out that the average atomic mass of this sample is 15.995. All right, so now what element do you think this might be? Well, we would look on the periodic table and find the element that has an average atomic mass of 15.99. And guess what we find? Oxygen. So this number was calculated using data similar to this. All right, so I want you to practice calculating the average atomic mass of this particular atom, this particular element, and what element do you think it is? Okay, so I want you to try it. You multiply those together, then you add that up, and then you divide by 100 to change it from percent. So what element do you think it is? Okay, so just to review, and I like to play music when we review, remember, atoms are neutral. Ions have charge. Cations are positive. Anions are negative. The atomic number is the number of protons. Mass number is protons plus neutrons. And then you should be able to write the symbol and name of an isotope. Tell me how many electrons, protons, and neutrons there are. And then calculate atomic mass by multiplying abundance times mass and then adding them together. Alright? Fun times. Did you have your carrots? Did you take your notes? Hopefully. We'll keep talking. It's been fun. Oh, hey. 5 things you should be able to do after seeing this video notes. Peace out from Harbs.